Question 4 says a student investigates the reflection of light by a plane mirror. The student uses a ray box, a ruler, a pencil, and a mirror. Part A, name the apparatus that can be used to measure angles during the investigation. What do we use to measure angles? It's a little thing called protractor, and I hope you've brought that to the exam. This is what a protractor looks like. Part B, the diagram shows a ray of light directed to a plane on the mirror. So the ray of light is this. That is the ray of light. And you can see the direction it's going down into the mirror, which is this horizontal plane on the bottom. And then it says label the angle of incidence. Right, let's make this a multiple choice. Which one is the angle of incidence? A, or is it B, or is it C? Which one? Angle of incidence. The answer is B. The answer is B. And the reason for that is because the angle of incidence is always measured between the ray of light and this dotted line drawn here, which is perpendicular 90 degrees to the mirror. Do you see that 90 degrees? This is important because sometimes they really do tell you to label this vertical line, which is called the normal. And now you know why it's important, because you need the normal in order to measure the angle, this angle of incidence. And that's what we're going to do next. Measure the angle of incidence. You're going to whip out your protractor, and then you're going to line it up. You're going to line the 0 up here, and then you're going to see how much this is. And it should work out to be around 79 degrees. And just so you know, the mark scheme accepts anywhere between 78 to 80 degrees. So don't get this too far off. It can't be too wrong when you do the measurement. And the last bit, part 3, complete the diagram to show the ray reflected from the mirror. Okay, so when you draw a reflected ray, the most important thing you have to demonstrate is the symmetry. Because if I just take this out of the way, when this green ray is going into the mirror, you would expect it to be reflected, and it should be reflected the same amount. So if this angle is 79 degrees, it should also be reflected by 79 degrees, okay? Therefore, the ray reflected from the mirror would look something like this, right? Now, don't go too wacky. I mean, don't draw like this or like that, because that's clearly wrong. So somewhere, or you can even use your protractor to make sure that it's literally 79 degrees. So this would be called the reflected ray. And I'm just going to label this as well. So the green ray is called the ray of incidence. Ray of incidence. And then the blue ray is called the ray of reflection. Ray of reflection. Okay. Question 5. A driver of a car sees an obstruction in the road ahead and must stop the car. State the formula linking average speed, distance traveled, and time taken. So this is speed is equals to distance over time. And these equations are usually used for the second parts of the question. So it's not just telling you to write it, it's useful for the rest of the question. So the car is traveling at 21 meters per second, and then the driver's reaction time is 0.14 seconds. Calculate the distance traveled by the car during the driver's reaction time. So I want to make sure everyone knows what's going on here. So here is the car. Here's the car, and the driver is here, right? The wheel is here. So the car is traveling this way towards the right-hand side. And then you see a bunny. The driver sees a bunny. And when it sees the bunny, it needs to stop the car so it doesn't hit it. And the reaction time is the time between seeing that bunny and hitting the brakes. That's how long it takes. So it takes, the moment he sees the bunny, it takes 0.14 seconds later before he reacts by hitting the brakes. And during this 0.14 second before he's hit the brakes, the car is still moving, right? So that distance is what we're calculating. Understand that the distance covered by the car before it starts to brake. Right, now let's just substitute the things into the equation. Now, a few steps for doing equations in physics. You must do the following. You write the equation, and then you rearrange, which means that you have to write the correct subject. In this case, they want you to find distance. So your distance needs to be the subject. So you have to rearrange. That's what I mean by rearrange. After you rearrange, then don't calculate yet. First of all, you would check the units. Checking units means all the units are consistent with each other. So here, the distance they want is in meters. Therefore, the speed has to also be in meters per second, not kilometers or millimeters per second. Similarly, the time is in seconds, and therefore your speed also has to be per second. Make sense? So if they gave you this in minutes, then you have to times by 60 to make it seconds before you can proceed with the calculation. And only after that are you permitted to calculate, right? Okay, so having done that, let's do exactly this. I need to move the bunny closer to the car so I have some more space. So I already have the equation. It's written on the first part of the question. I need to rearrange, and rearranging it will mean that distance is equals to speed times time. And my units are correct. I already checked them. And the speed is 21 meters per second. The time is 0.14 seconds. So if you punch that into your calculator, you should get 21 times 0.14, 2.94 is the answer. And make sure you read the question. Sometimes they ask you to write it to 2 decimal places or 1 decimal place or 2 significant figures. Read the question carefully. Okay, the next part. Here it says the car experiences a braking force of 7,600 newtons. And the mass of the car is 1,200 kilograms. State the formula linking force, mass, and acceleration. Force equals to mass times by acceleration. And then next part says calculate the acceleration of the car. So let's use the same 4 steps here. First step, equation. I got that. Second step, rearrange. Who's my subject here? What are they wanting? They want the acceleration. My acceleration has to be the subject. So let's rearrange. Acceleration is equals to what? Is equals to, I'm going to bring mass over here by dividing, right? So force divided by mass. So I've rearranged it. Check units. Are all my units correct? Meters per second squared. Kilograms for mass. Newtons, that's all good. Now I can calculate. So therefore, this would be force is 7,600. The mass is 1,200. And if you do that on your calculator, you should get 6.3 recurring. So 6.3 meters per second squared. There's one step here that we haven't done yet. Just sometimes in physics, you don't just do the calculation and write down the number. You have to think if your answer makes sense. Look at what's happening here. Remember what's happening? This car is braking because it doesn't want to hit the bunny. Therefore, should it be accelerating or decelerating? If it's braking, it should be slowing down, right? In fact, it should be stopping. So it really should be decelerating. So don't you think it makes no sense to say that it's accelerating at 6.3 meters per second? Then you're going to hit the bunny even sooner. So what this means is the acceleration is actually negative because it's actually slowing down. It's actually slowing down. So the sign should be a negative sign. So you can think of it as it's accelerating in the opposite direction and therefore it's decelerating in the forward direction, which means it's slowing down. So little details here are important. So the A is actually negative 6.3. That's important for the next part of the question, which is to calculate the braking distance traveled as the speed of the car is reduced from 21 meters per second to 0 meters per second. So again, those 4 steps, right? Write the equation, rearrange, check units, and then calculate. So what's my equation here? It's not like the previous parts of the question where they wrote the equation for you, basically, right? So in this case, you have to figure out the equation. So how do you figure it out? You look at what you have. You have distance, and then you have speed. And actually, there's 2 speeds here. There's the 21 meters per second, which is just the initial speed. I hope that's ringing a bell for some of you guys. Initial speed. And then 0 meters per second, which is final speed. So I've got initial speed, final speed, and distance. Anything else that I know? it would help to scroll back up and see what other information you just calculated. That's supposed to help you for the later parts of the question. And it turns out that A, acceleration is negative 6.3. So I'm also going to write that down here. Acceleration is 6.3. Acceleration, oops, I meant 0. Negative 6.3. Now, what equation involves acceleration, final speed, initial speed, and distance? If you look at the formula booklet, you would see this equation. V squared equals to U squared plus 2AS, where V is equals to the final speed. U is the initial speed, and then acceleration is acceleration. And what does S stand for? S stands for distance, not speed or anything like this, distance. So I've got the equation, number 1, step. Number 2 is rearrange. Rearrange to make who the subject. Who is the subject? I'm trying to find distance here, so I need to make S the subject. So let's do a little rearranging here. So V squared equals to U squared plus 2AS. I'm going to isolate the S, so I'm going to move the U over first by subtracting. So V squared minus U squared equals to 2AS. Now I need to move the 2A over by dividing, because on the right hand side is being multiplied by S. So here I'm going to divide. So V squared minus U squared divide by 2A equals to S. Now I can substitute. And of course I've checked all my units already. So V squared, V is 0. So that means 0 squared minus 21 squared divided by 2 times A. A was negative 6.3 recurring, right? Now, let me do this calculation. So 21 squared. So 0 squared is just 0. 21 squared is 441. And then 2 times negative 6.3 recurring is negative 12.6 recurring. And this would equals to, 0 minus 441 is just negative 441 divided by negative 12.6 recurring. If you did that on your calculator, you should get divided by negative 12.6. Did you get 35? I got 35. And you see how here the two negatives cancel out, right? To get 35. So 35 is our answer. And does it make sense? Again, ask yourself if it makes any sense. It means that the distance it has traveled as it decelerates from 21 down to 0 meters per second is 35 meters. I hope that bunny is farther than 35 meters from the car, or else it would have hit the bunny before it's fully stopped. Okay, question 6 says a person throws an object vertically upwards. When you read physics questions, picture it, imagine it happening. Now, this person is throwing an object vertically upwards. Let's picture that. So this is you. And you're going to throw an object vertically upwards. Let's make this object like an apple, for example. And this apple is being thrown upwards by you. And the speed time graph shows how the speed of this apple varies from the time it is thrown until reaching the maximum height. So let's say the maximum height is here. I mean, that makes sense, right? Like when you throw an apple, it's going to go up into the air and then it's going to reach some height maximally and then fall back down because gravity. Get it? Now, this graph, make sure you understand what's happening. At the beginning of time, the speed of this, look, this graph represents this journey of the apple from this point up to this point. So point A is at the beginning of time, and then point B is at the end of time, which is at 0.45 seconds. So during this journey, how's the apple moving? Is it going to, there's only 3 ways something can move in physics. It's either accelerating, 4 ways: accelerating, decelerating, constant speed, or stationary. So this apple, as it goes from A to B, is it accelerating or decelerating or constant speed or not moving? It's going to slow down. It's going to decelerate. Wouldn't you agree, right? Because it's going to be really quick at the beginning. And that's why at the beginning, it's got the highest speed. And over time, it's going to slow down and then it's going to just reach the maximum height at 0. So it's decelerating. And that's why this graph starts off at the maximum speed and then eventually drops to 0 speed. Does that make sense? You have to understand the graph before you can go on to answer questions about a graph. Okay, now it says calculate the acceleration of the object. Acceleration, if you guys remember, is actually basically change. The triangle means change in physics. Change of speed over change of time. Change of speed over change of time. So the change of speed, if you have math vision, it's a special talent, you can see that this is actually the gradient. When you see a graph in physics or in any science paper, try to think of the gradient. Describe the gradient, calculate the gradient, use the gradient. It's usually a very good way to get marks. So in this case, the change of speed is basically this. It's the vertical part of this graph. It's changing from 4.2 down to 0. That's the change of speed. So that. And then for the change of time, that is the bottom, right? So this is really the gradient. If you guys remember, gradient is equals to y2 minus y1 over x2 minus x1, right? x2 minus x1. So y2 is this number, that's 4.2. And then y1 is this number, which is just 0. And then similarly for x2 is this number, 0.45. And then x1 is 0, so right? So 0.45 minus 0. So if you do that calculation on the calculator, that would be 4.2 divided by 0.45. That would give you 9.3 recurring. So 9.3. Now, does this make sense? Have you checked if your answer makes sense? Is the apple accelerating? It's definitely decelerating. And in fact, the fact that the graph gradient is negative tells you it's decelerating. So really, it should be a negative acceleration. In other words, it's deceleration. It's slowing down as it travels up into the air. It was eventually going to stop. Right. Okay, calculate the distance the object travels to reach its maximum height. Whenever you see let's look at the whole graph. Whenever you see a speed time graph, you should automatically know that the distance is represented by the area under the graph. So this is simply a calculation of the area of this triangle, which is base times height divided by 2. That's the formula for area of a triangle, right? So the base is this length here, which is 0.45 times by the height. The height is this green length here, which is 4.2 divided by 2. On my calculator, 0.45 times by 4.2 divided by 2, that would give us 0.95 meters. So that's important, calculating the area under a speed time graph to find the distance traveled. Okay, part B. A different object is dropped from rest and begins to fall. So again, let's picture what's happening. Here you are again, and in this case, you are now dropping, like I guess the same apple, and it's going to travel down. You're dropping it onto the ground. And the graph shows how the speed of this apple varies with time. So do we understand what's happening now? At the beginning of time, it's got a speed of 0. That makes sense because that's before you drop the apple. It's not moving at all. And then as you drop it, think about this apple. It's going to, right? It's going to hit the ground. And it's not going to be traveling at constant speed because it will accelerate due to gravity. It will accelerate due to gravity. And that's why the gradient is positive. It shows the acceleration. Eventually, though, it reaches this plateau, which means that the speed is no longer changing, right? The speed is around 1.5 something. It reaches this constant speed. So this graph, this bit here, remember I said just now, the motion of an object can only be four things: accelerating, decelerating, constant velocity, or stationary. So what is this? Between A and B, is it accelerating, decelerating, etc.? It's accelerating because the gradient is positive, acceleration. And then between B to C, what's the motion like? How's the apple moving here? Look at it. The speed is not changing, so therefore it's constant speed. Constant speed. Okay. Give the name of the two forces acting on the object as it falls. So this is your apple. That's your apple, right? Apple. And what are the two forces? You have the downward force called, do not say gravity. Gravity is not really a force. It's called weight. There's weight. And then you have the upward force, which is something called drag, or you can also say air resistance. If you imagine you dropping through the air, you can imagine the air is like going up against your face, right? That's the air resistance that we're talking about. So that's the answer for this. There's weight, and then there's air resistance. And if you want to be extra detailed, weight acts down and air resistance acts up, because forces are vectors and they have a direction. And it says draw arrows on the diagram to show the force acting on the object at B. Okay, so at B, let's zoom out. At B, has it reached constant speed yet? It hasn't. It hasn't. Why is that important? Because when it reaches constant speed, which is a horizontal line here, it would have balanced forces. So this is the most important point. When things are accelerating, according to Newton's law, right? Accelerating means forces are not balanced. Forces not balanced means that the downward weight is larger than the upward air resistance, not balanced. And when it's traveling at constant speed, it means the forces are balanced. Forces are balanced. That's why it's traveling at constant speed. So since B, the forces are not balanced because it's not reached a constant speed, which is the horizontal part, then how would you draw these forces? They cannot be balanced, right? So the size of these arrows cannot be balanced. Which one's bigger then? Weight or air resistance? Have a think. Which one's bigger? Let's say this is weight. How should I draw the air resistance arrow? Should it be larger or smaller? Definitely smaller, right? Definitely smaller. Because if it's bigger, then the object will fall upwards. And that doesn't make sense because you're dropping the object. So it should be moving down. So that's how you do it. And just to really draw your attention, the mark scheme is looking for correctly labeled arrows, the direction of the arrow, and the last mark is 3 marks, right? The last mark is the fact that the weight has to be a longer arrow than the air resistance. In other words, to show that the forces are unbalanced, that weight is larger than air resistance. Longer arrow. Right, so last part, it says explain the shape of the graph from A to C. You should use ideas about forces to help your answer. Okay, so I've got the graph here. You have to explain. I would like to split this graph into 2 parts, which is A to B. Let's make that the pink part. And then B to C, which is the green part. And for each part, I'm going to talk about 2 aspects. Number 1 is the forces, and number 2 is the motion. This is the whole unit, right? It's forces and motion after all. Okay, so between A and B, just imagine that apple. Remember, we're dropping this apple on the ground, right? So between A and B, what are the forces acting on this apple? You've got the downward force, which is weight, label that. And at the beginning, there's not very much air resistance. So there's almost nothing, because the moment you drop the apple, the only force acting on it is the weight. So that's at the beginning. And then a little later on, like maybe at this point, right? What happens is, imagine that apple, the weight is still the same. The weight is the same. It should not increase or decrease because it's not on a diet, it's not gaining weight. So the weight is the same. So same length for the arrow. But what's happening now? The air resistance is building up a little bit, right? So the air resistance is increasing a little bit, you would agree. right? So this is what's happening in the pink part of the graph. You have the weight acting at just the very beginning, and then later on, the air resistance starts to build up a little bit, and hence you have the air resistance acting upwards. Now let's think about the motion. Remember Newton's laws. If the forces are not balanced, then the object will accelerate. Therefore, both of these, it's accelerating. It's accelerating. So I'll write that down first. Accelerate and accelerate. The other thing you have to mention is, why would air resistance increase, right? At the beginning, there's not much air resistance, and now it's increased a little bit. Why would it increase? Air resistance increases because velocity increases. And this makes sense. If you just imagine, if you're this apple, right? At the beginning, you're dropped from someone's hand. And as you fall through the air, you accelerate. That's what happens when you fall, right? You accelerate, you fall faster. So the faster you fall, imagine that air blowing up against your cheeks, like that's the air resistance. So the faster you fall, the more that air blows up, around your cheeks. Do you understand? So that's why as velocity increase, as you fall faster, the air resistance will also increase. That's the pink part. This whole bit is the pink part. So that's the pink box. Right, so then we explain the green box now. So at the green box, imagine if sometime later, so this moment now, the weight is still the same because, again, our apple has not lost or gained any weight. And at this point, the air resistance increased a little bit more. See how this arrow is a little bit longer than the previous arrow. And it now is equal to the weight. It's now equal to the weight. And Newton's law says if the forces are balanced, then what's the motion? The motion will be constant velocity, constant velocity. And this is also called the terminal velocity. That's a key word. Terminal velocity is like the final velocity that you're falling. You're not going to fall any faster than that. So this is the terminal velocity. So this is basically how I explain this graph. I want to just embellish the answer a little bit more. Apart from talking about the forces, you also want to talk about, is it balanced or not balanced, right? Like write it down. You know it, but you have to write it down. So in this case, in the pink case, force is not balanced. And in fact, tell me more. Always say more. How not balanced? The weight is larger than the air resistance. And in the green situation, the forces are balanced, right? They are balanced. How? Which one's balanced with what? The weight is equal to the air resistance. This question was 4 marks, and this diagram that I've drawn out for you, it covers all of the marks. One more point here is that when the forces are balanced, this is called no resultant force. It means there's no overall forces acting on it because it's canceled out, right? The upward air resistance is canceled out the downward weight. So I'm just going to zoom back out. You can see everything. This is a typical question on some object falling through the air, accelerating, and then reaching a constant, i.e. terminal velocity. Usually 4 to 5 marks on a physics paper. Make sure you can answer this question. Talk about the forces and the motion, and then Newton's laws. Main points from this video: yellow box. This is such an important box. I even made it glow. Do you see that? These are the 4 steps you take when you do calculation questions. Don't forget point 2 and 3. A lot of my students forget to rearrange and check units, and then their calculation is wrong, or they don't get the method marks. So 1, 2, 3, 4 in that order. Purple box, this is a velocity time graph, and there's 2 things I want you to take note of. Number 1 is the gradient. The gradient represents the acceleration, and you calculate the gradient by dividing rise over run. The second thing to take note of is the pink area that I've colored in. That represents the distance traveled. I repeat, the distance traveled is equal to the area under the graph in a velocity time graph. This equation, force equals mass times acceleration, is very familiar, but I just want you to remember that acceleration is a vector. So you need to remember the direction, and in this case, it was negative. It was negative because the car is actually slowing down, which means that its acceleration is actually negative. Okay, blue box, this is on angles. This is called a protractor, and you're going to remember to bring that to the exam. And when you measure angles, please draw the normal, which is perpendicular to the surface of the mirror. And then you measure all of your angles from the normal. So from here to here, that's the ray of incidence, and therefore the angle of incidence. And from here to here, that's the angle of reflection. Lastly, the pink box, this is on terminal velocity. Terminal velocity. These are usually 4 marks on the exam, so make sure you mention the forces acting on the object. Downward force is weight, upward force is air resistance or drag. You talk about the motion. Is it accelerating or has it reached terminal velocity, in which case it's traveling at constant speed? And I also talk about whether the forces are balanced or not. When they're not balanced, it's accelerating. When they're balanced, it's traveling at constant speed.